So we looked at two operators, right? We looked at concatenation and replication. And the cool thing is they look just like plus and minus, and that's why they're called operators. There are also things, other operations, not operators, that are called functions that work with strings. And the one we've been working with the most so far has been has been print, but we're not going to get to that quite yet. First, we want to look at something called length. So if we type in something like s equals hello, I think for right now I'm going to stay in my Anaconda or in my PowerShell because I'm not sure if I have any more tabs coming up. So we can have s hello. S now has the value of hello, and one of the things we can do is we can ask for the length of s. Just hit return. Enter will give you a new line. Okay, so now if we ask for the length of s, right, what that will do is it'll just count up all the characters in s. So starting at the H is 1, E is 2, L is 3, L is 4, O is 5, the exclamation point is 6. So that gives us the length of the string. You can, when we learn lists and things like that, you'll find that length can be applied to other types of data organizations as well. But for strings, it counts up the number of characters in the string. I told you that we had something called an empty string. We can ask it, and by the way, we can do this for a variable, or we can do this for just a literal hello world. How many mistakes can you make typing a 5-word letter? Right, so hello world is, well, there's 5 for the hello, there's a space that's 6, and 5 for world. That gives us 11 characters in that. I did mention we have this null string, or the empty string, which is just 2 double or single quotes nested together, right? There's 2 single quotes together. And the length of the empty string is, as we hope you would expect, 0. That's why it's called the empty string, right? If you have 0 eggs in your egg carton, that's the empty carton. So the same thing with the string. Where are we? Yep. So the question is, in languages like C, what you would normally put in is you'd put a null termination to signify the end of the string. And the question is that the same as in Python? And the answer is probably. But I don't believe the Python standard says exactly how you have to represent strings. Strings are something that's called immutable. So once a string is declared, you can never change any of the single characters within it. You can change if I have a string in variable s, I can change what string s represents, but I can't change any individual character within s. That string, as encoded in memory, has to be immutable. So what I'm saying is probably, but it doesn't matter because you can't overwrite that null termination. And the unless the mechanism for how you store strings is specified in the standard, you're free to use whatever abstraction, whatever data structure you want that meets the abstraction. So, for example, you could store the length of the string and then not have a null termination. The length of the string could be the first byte or something. Make sense? Yeah, I could look into it more and give you an exact answer, but because of the abstraction, because I was looking at that actually earlier yesterday. Because of the abstraction, it doesn't actually matter. And we'll talk about what immutable means when we get into lists. No, Python's Python based, I believe. A lot of the no, that's probably not correct. The interpreter is probably written in C, but it's its own language. There are a lot of languages that bind into Python bindings. So if you have a computationally intensive part, you can write it in C and then publish a binding that allows the Python interpreter to call it. But you could do the same thing in Java or in assembler, or in in a variety of other languages as well. So Python is its own, it's like it's its own language. I expect that a lot of the interpreters are probably written in C, but that doesn't mean it's a C-based language so much. You will find a lot of the underlying constructs, at least mathematical constructs, are implemented in C or in another fast language to give you speed ups. We'll later in the semester we'll do a sort, and we'll show you the difference in timing between a sort that we write and a sort that an equivalent sort that's callable from Python that was written in the C language, and it makes a difference. It makes a fairly stark example. Okay. So I have 15 minutes. Can I do this in 15 minutes? Yeah, I can do this in 15 minutes. Yeah, most of it. Okay. So we did the length function. The next function we want to look at is the string function. So we have this function called str. Actually, we have three functions. We have str, we have int, and we have float. And the cool thing about them is they take values of other types and try to convert them into the type they are. So for example, string will take integers and floats and try to convert them into strings. Int will take floats and strings and try to convert them into integers, and float will take integers and strings and try to convert them into floats. So let's kind of see this working. If we have a string, we can type in whatever we want, including that number. And what we'll get out is we'll get a string. Let's throw some other characters in there. Right? What we'll get out is a string representation of that number. Okay, so this is no longer an integer. This is no longer a float, right? This is a string, and this is a string. But they do actually specify as closely as we can due to precision. Let me kill some of these so that we get all the digits, or more of the digits. There we go. They do actually represent the value that we supplied, right? And we can go back and forth, right? If we have a float or an integer, we can go into string. If we have a string, like, right? If we have that, the string whose characters are 5, 4, 7, 6, 4, we can convert those to an integer, right? And now we can do calculations with it, +2. Right? Or we can convert it to a float. Right? Integer rounds. So integer doesn't round down. Integer truncates. Okay, so it just takes and throws away the decimal. There are ways, right? So it's not rounding, it's truncating, because you can't, it only counts whole numbers, and partial numbers don't count. So yes, well, and again, the only thing you have to be careful of is with negative numbers. Yeah, it's still truncating with negative numbers, but when you start getting into the double slash and the % sign, the modulo, you have to be a little careful that it's doing what you expect it to do. But yeah, that should they do truncate. And you just chop off the decimal part and throw it away. There are other operators like round and ceiling and floor that allow you to control that, but they're different, and we'll talk about those later. So yeah, so it only affects the answer. It only affects what's returned. Okay. All right, so we can convert back and forth between all of these. One thing we can't do, for example, is if we have, well, this we can do, right? We can provide decimals to floats, and that will work. But if we try to provide a decimal to an integer, that'll throw an error because it's expecting to see an integer and what it's seeing is a float value. Now the funny thing is if we do something like this will work. Oops. What happened? There we go. If we come in here and do a float, convert it to a float first, and then apply the integer operator, integers, when supplied with a float, truncate. But when we're supplied with a string representing a float, throw an error. So that's just one thing to be a little bit careful of. So all of these are ways to convert back and forth. We will hit them shortly. I may end up, well, let's see where we get to. We'll have to use them on our input function is kind of where we're getting. So finally, one more thing. We have the print function, and we can do something like help print. And what you're going to find out is there are a couple of things for the print function. Right? This tells you how to use the print. It says you can have any number of values. Right? You've seen that we've done like print. Print help 7, 8. That'll be good. Right? And that'll print out help and then 7 and then 8, right? These 3 arguments are values, so you can have any number of values. And then you have the rest of this stuff. And the rest of this stuff kind of tells print how you want it to behave. The file system allows you to redirect it someplace else. Right now, the default is just to print it out to the screen. We're not going to worry about that one too much, but it exists and you can use it. The flush one, flush equals false, is more efficient I/O. And that's the default. So what flush equals false means is it's accumulating your output in a buffer, and then when it gets a break, it'll print it out. If you want to print it out immediately, and this won't do anything for the example we're doing, but you can say something like flush equals true, and that is a less efficient form of printing, but it'll print every line as soon as it hits it. So if you're trying to debug your program, and you're in a loop, and you're printing out your loop counter, and you don't have flush equals true, you could be 9, 10, 1,000 loops before your program's crashing, the value you're printing out. So this is when you're debugging and you want to know where you are exactly in your program, you always want to use this flush equals true. And I'll harp on this a couple of times. I just want to expose you to it now and let you know that it's there. What we really want to talk about right now are these other ones, sep and end. So this is what your output normally looks like. And actually, you know what? I need to go to where is it? There we are. I need to go to my Python interpreter here. Print s comma t, and we'll say t equals world, because I want this to work. Okay, so when we run this, right, we get hello world. And if we look at the help for print, what we'll see is we have values, then we have this sep parameter, and it's equal to, the default is equal to the string with one space. And then the end is equal to the /n. So if we do something like print s, and then we'll do print s again, print st and then print s, and then run this, what we'll see is that between the words, between the values, signified by this comma, we put the sep value. We put a space. And at the end, when we're completely done with our values, what we do is we put out the end value, which is the /n. So we print hello world, our 2 values are ended, we go down and we just print hello. We can control this behavior with the sep. So if we do sep equals, let's say 4 stars, what that says is that says when we come to this separator between our 2 values, instead of printing out the space like we're used to, we print out 4 stars. And notice it's instead of the space, it's not in addition to the space. We can make this whatever we want. We can make this a /n in there if we want. right? And now it prints out 2 stars, a new line, 2 stars, and then world. So we have full control over this. And we also have full control over the end value. Now I've taken out the sep, so the sep will now go back to a space, but I can do something like end equals the empty string. And when I do that and run it, what we'll see is that this next print, right, when we get to the end of this print, we're no longer putting out a new line, a /n. Instead, we go right down to the next print, and that print starts off at the end of our next print. And by the way, these have to be specified for each value. You know, if we wanted this one to behave similarly, we would have to put the sep and the end there as well. And we can combine these. We can put 2 stars there, and then we can put star star /n dash dash dash, something like that. Okay? Oops, what did I do? Oh, needed quotes. Okay. All right, so you have full control over how your data comes out, over how things are actually printed and how they look. We talked about that. I think the last thing I want to do is just quickly, we have 4 minutes. I want to quickly get into user input, just so that you've been exposed to it. You have the ability to take input from the console. So we can do something like print, enter your name. And then we can come down and say x equals input. Spell it correctly. And then we can print x. Okay, and if we run this, what we'll see is it comes down here. It says enter your name, and you can enter your name, right? And then it comes out and it prints your name, and I got a W in there now. Okay, all input comes in strings. So if we say something like enter a number, and then we'll print x times 4 just to show what's going on, right? We're going to enter an integer. I'm going to enter 30. I'm going to come over here and enter 34. And what it's going to do is it's going to take that, and we hit this 4, instead of multiplying it by 4, it's going to do string replication. So if we want to actually cast this to an integer or cast it to a float, this is where our int functions come into play, or our float functions come into play. And now if we come down here and enter an integer 34, we'll actually do the other multiplication by 4, the integer multiplication by 4, and we will print out our 136. Now this is kind of cumbersome, and you can see that we come down here and we have some extra lines. You can actually combine this, and you can actually put the question right within the input. Okay, and actually what we're going to do is we're going to break up a little bit differently. Here we're going to ask for the input. We're going to keep the input as a string for a second. And then we'll come down here and we'll say x equals int x, and then we'll print 4 times x again. Okay, and now I can come in here, right? And now you can see that the prompt's right on the same line. I should probably have a space in there. Try this one more time. Now, it's waiting for me to enter something. Run this again. Okay, now I can come in here and I can enter 34. And it's still a string at this point. We'll convert it to an integer, and then we'll print it. In general, this is what we're actually going to want you to do. I'm going to take this out for now, but when we get to submittee, we're actually going to want you to do a print X. I'll leave it in there. And we're going to do that because of some of the vagaries in the way we have to run programs when we're doing our auto checking on submittee. But this is the format you're going to want to do when you're inputting any value. Right. Taking the value will be a string, immediately print it back out again. This is, on your tests in real life, you don't need this. This is just for submittee. In fact, I'll just comment this out so that you know that this is something that we have to be thinking about, but we don't have to do it. Then convert it to an integer, and then do your calculations with it and run. So we would do like 34 here, right, and 136. The reason for this is, what if somebody runs this and they don't know what an integer is, and they enter 35.6? If we just do our conversion here, we have no chance of checking it. Down here, we can actually do something before we hit this x equals integer x to make sure that it's a valid number. All right, that's all I have for you today. Work through the practice problems. There's 2 sets of them. The practice problems are between the sections, right? So I showed you the first set. The second set is down here. Work through them, make sure you understand them. They're good learning points, summary, and then we have exercises. I will do the code from class at the start of class on Thursday. These lecture exercises, these are the Lecture 3 lecture exercises. These will be due next week. Okay, don't worry about these now. Do them, get them correct, but don't worry about submitting them now. We will give you an opportunity to put them into submittee next week after you've actually had the lab on submittee. All right, thank you.